You may pause the video and try this problem by yourself first. So we have a hot chocolate and it's cooling down at a rate of dt. I changed to capital T. That's the temperature change rate as time ticks. That's dt is equal to negative 0.05 multiplied by temperature minus 75 degrees Fahrenheit. It says per minute, so T is per minute, and where capital T, I should change to capital T, represents the temperature of the hot chocolate, and little t is time in minutes. Okay, so if the coffee was at initial temperature at time t, I'm going to set my x value as little t, time t, 0 minute, capital T, the temperature. So at 0 minute, the initial temperature was 160 Fahrenheit. Okay, so that's the initial value right there. So we have a point, and this is the rate that temperature drops. Okay, what will its temperature be at 10 minutes later? So 10 comma what? Okay, that's what we need to find out. Okay, now we have capital T on the right side, so I'm gonna divide this term over here. We're gonna separate dt with d, well, d capital T with the d little t there. Okay, so if I divide that term, let's see. So d capital T over t minus 75 should equal to negative 0.05 times dt. Okay, that's just the unit. You don't have to worry about that. Okay, so far we have this. Let's move it up a little bit. So we need to find the equation. In order to get rid of the dt and dt here, let's integrate it. Integrate here, that's just constant, so I could just integrate over here. Then we're gonna get, when you integrate this, imagine this is ln absolute value of capital T minus 75. That should equal to negative 0.05 multiplied by little t plus c. Now we need to figure out what c is. Let's plug in the value that we know. Little t for 0, so I'm going to plug in 0. So we're going to plug in 0 here, and capital T 160. So let's do that. So natural log of absolute value 160 minus 75. That's just a positive number, so we could get rid of the absolute value. It's going to be 85. That's going to be equal to negative 0.05 times 0, which will be 0 plus c. So c will be, since this is 0, natural log of 85. So we have c right now. So all we need is just plug it into that formula we have. So instead of c, I'm going to write natural log of 85. Okay. Now we need to solve for capital T here. So we're gonna e both sides. So when we e it, we got absolute value of t minus 75 is going to be e to the negative 0.05 t plus natural log of 85. Okay, this is whole exponent. Well, you could separate this by saying e to the negative 0.05 t multiplied by e to the natural log of 85, which becomes 85. So you could just put 85 here if you want. Okay, you could do that. Let's just do that then. Let me simplify it a little bit more. So we have absolute value of t, temperature minus 75 is going to be 85 times e to the negative 0.05 little t. Okay, now let's get rid of the absolute value by saying t minus 75 is going to be plus or minus 85. And we know it's going to be positive because temperature, hold on, e to the negative 0.05 t. We could check by putting in the initial value that we already have. We had little t 0 right here. So it's 0 by plugging 0, 160 in, whether it's positive or negative. Let's do that right now. So 160 minus 75 will be 85. Is that equal to positive or minus 85 times e to that 0, right? So that will be 1. So 85 is equal to positive 85. So we could get rid of that plus or minus and just keep it positive. Okay? Now, capital T is going to be 85 times e raised to the power of negative 0.05. Little t represents the time in minutes plus 75. So we have equation now. This is the equation to find what the temperature of the object is, or in this case, hot chocolate will be after t minutes. 10 minutes later, so all we need to do is plug 10 to little t and figure out the hot chocolate temperature. Let's do that. So temperature after 10 minutes, you know what? I'm going to write T of 10 is going to be 85 times e to the negative 0.05 times 10. And then we're adding 75 to it. Okay, so that's going to be 85 times e to the negative 0.5 plus 75. And then calculator time. It's going to be 126.555 and on and on and on. So I'm going to round it up to be 127. How about that? 127, our unit was degrees Fahrenheit. Okay, so this is how you do it.